Okay, everybody got that? All right. Now, this kind of might help you draw a little bit of some connections between kind of what we're trying to do. On the right-hand side of your paper, write these down. Okay, now we've talked about 3 different methods that you guys can use, okay, to graph lines. Okay, the first method was what? X and Y intercepts. What do you know about X and Y intercepts? How many points is this going to give you? 1 and 2. How many points do I need to graph a line? 2 at minimum, 3 at most, right? 3 or 4 at most, all right? There's a whole bunch of points that lie on that line, though, right? You guys realize that? Hello, you guys with me? Wake up time, communicate with me. Okay, it always helps go a lot faster when you guys communicate. Okay, so what do I know about the intercepts? If it's an x-intercept, what's y is 0? Good. That's automatic, right? I can plug that into my equation. Does it matter if it's in slope-intercept form or standard form? Doesn't matter, does it? Ideally, we probably use or find the intercepts when we have an equation that's in standard form, because that's the easiest thing to do. Okay? And then for the y-intercept, it's always what? X is always 0. Good. Okay, just plug it in, solve for the other coordinate, right? Okay. The second method was what? Input, output table. What was the form that had to be? Had to look like what? Had to look like y-intercept. But if we didn't really use y, what did we use? F of x equals mx plus b. Okay, what is this called? You guys write this down. This is called, who said it? Good. It's called function form. Okay, it's called function form. Basically, that just means for every input, there's exactly, or when you have an input, you're going to have a output. Your output is a function of what? What your input is, right? If I work 9 hours, how much money am I going to make or make? Does that make sense? Okay, my input is going to be number of hours I work. My output is going to be my wages, right? How much I get. You guys with me? Okay. The other method was what? Slope intercept form, right? Now, this comes in many different forms. What are the different forms? They come in standard form. They come in point slope form, right? There's a couple other forms. Sometimes it won't even look like it's a form, but you still have to. It all comes back to what? I'm all coming back to slope intercept form. Can I graph a line when it's in standard form? No. I have to make this what? Slope intercept form. And I do that by moving the x to the other side and then dividing by what? Whatever b is. You guys writing this down? Okay. Can I graph a line in point slope form? Sure I could. All I need is a slope and a point. Don't I get that from here? We don't ever do it though. Okay? We always try to put it in slope intercept form, right? That's real easy to do from there. And okay? It's all about writing equations. What's the equation? I just told you to graph this line, right? What would it be if I wanted to write an equation? What would it be? Y equals 1x plus what? No. Where's my y-intercept? 0, isn't it? Okay, so write that down. Write it on the coordinate graph if you want to. Now, is there another way that I can write this? Yeah, I can say y equals what? This is the way you're going to see it. Okay? Y equals x. Now, we call this, write this on the side because you need to know this. We call this a parent graph. Call it a parent graph. This is the graph that all other graphs stem from. Does that make sense? Okay, so what happens to the graph? What happens to the graph if I add a 1? What happens to this line? Yeah, it just shifts up, doesn't it? What happens if I add a 5? Shifts up. Notice the slope stays the same though, doesn't it? Has the pitch of the line changed? Okay, what happens if I go -3? Telling you watching this? Why are you looking around then? Watch, okay? If I have a -3, then it just shifts down 3, doesn't it? See how that's working? Doesn't matter if I move my line like this, does it? I mean, I still have -3 as a y-intercept, but has the slope changed? No. It's still going to extend out. I'm just shifting it up and down. So remember at the end, if the b, or the y-intercept, if b changes, it just shifts it out, up or down. But if I put a negative in front of the x? What happens to my line now?
It goes the other way.
Yeah, it just flips it, doesn't it? It's just going to take this and flip it down. Let's see if I can do this. Okay, from that corner to that corner. I had it in my. Okay, did you see what happens, right? Okay, the same thing. What happens to my B if it changes? And the line does what? It shifts up or shifts down, but the slope stays the same. Okay? What happens if my slope what happens to the slope changes? What happens to my line here? Okay, what it makes it what? Steeper, good. It's just going to go up a little bit there. Okay, it's still passing through what? 1. Did I get it there? Just turns my line, doesn't it? Makes it steeper. And the higher the number goes, the steeper the line goes, right? What happens when the number gets closer to 0? What would be a number that's closer to 0? How about? What about a 1/2? Is that closer to 0?
Yeah.
So the closer it gets to 0, what happens? Then it has no slope, does it? And it flattens my line out. Eventually, if it gets to 0, what happens? There's no slope. It's a flat what? Flat line. Does that make sense? You guys with me? So then, if it's a flat line, it's going to be like 1 equals what? Wherever it crosses the y-axis. You guys with me?
Yeah.
Not right now. I need some time to get it together. Can you come back like after 4th hour? Okay, thanks. Okay? Does everybody see how that works? Okay, next slide. Okay, this is Write this at the top, absolute value. This is 4.7. This is kind of what you're gonna do today on your notes, but I wanna kind of go over it, just touch on it briefly and so you can see it visually what's happening.
You also like that one.
Yeah, make your V. Okay, notice on my V, what did I do? I started and then I extended out to the corners. And my V is a little bit bigger, probably need to change the size of it a little bit. Okay, what do you think the absolute value of what do you think the parent graph of that one is? If a straight line is y equals x, this is just a standard line, right? Okay, what would it be for an absolute value? This is you learn a lot just what I'm fixing to tell you. You draw a lot of connections here, okay? Watch this. The parent graph for an absolute value, you guys know what the symbols for absolute value are?
The
Two lines like this, right? So the equation for this graph right here would be y equals, guess what?
X.
Guys see that? Okay. What if I throw a negative? What if I throw a negative in front of that? What happens to my line?
It's really close.
It just flips, right? It just reverses. Well, what if I throw a negative in front of that? What happens to this? It flips down. Okay? It's basically going to just look like this. You guys see that? So I have the parent graph, right? So the parent graph is always going to look like that V facing up. If I add a negative, it's going to do what to it? It's going to flip it down. Okay? Now, what would my slope be on this? Let's flip it back up. What would my slope be? I'm going up 1 squared over 1, right? Up 1, right 1, up 1, right 1, up 1, right 1. So my slope is going to be what? 1 over 1, like so. What happens if this number changes in front? What happened to my line? My line got steeper, didn't it? So if I put a 2 in front of that, and this V is going to do what? It's going to get narrow. It's going to close up. What happens if it's a fraction? The closer to 0 it gets, it turns into what? A flat line. You see that? Okay, it gets what? Wider, doesn't it? Okay, so the closer my slope gets to 0, the flatter the line gets. Everybody clear on that? Okay. Is it kind of coming to you? You're starting to see it a little bit easier? Okay, now, what happens, and this is where you got to start making your connections. Outside the absolute value, what if I put a +1? What is that? That's my y-intercept. So what's this little point called right here? Everybody know that? Called the vertex, right? Okay, so if I put a +1, then my graph does what? Moves up a square. But the graph itself still stays the same, doesn't it? My slope is still the same. But if I put a +7 up there, moves up to 7, good. If I have a -4, then it just moves down to -4. So the B does what? Moves it up or down. Okay. Go back to the original. What happens if I put it inside? If I put it, you might want to write this down. If it's inside the absolute value, it's going to move it in the opposite direction of the number that you have. For example, you have a -1. So I'm going to move my graph which direction? Opposite direction of -1 would be +1. So my graph is going to move right 1 square. You guys see that? Okay. If it's a plus, then I move it which direction? I'm going to move it to the left 2 squares. You guys see that? Yes, no? Okay. Okay, so what if I put a there's a full equation. What's going to happen? Start at the origin, right? Start with your parent graph. What's the first thing it's going to do? It's going to flip. Is my slope going to stay the same? What's my slope? Treat absolute values just like variables. If there's no number in front of it, it's always understood to be what? 1. So my slope is going to stay the same, right? So I don't need to close it up or make it wider, do I? Okay. All I need to do is flip it and get my vertex down on 0, right? Okay, now, inside. Okay, so I'm going to go left 2, and then down 3. There's my graph. You guys see how we did that? And you can do that with just regular lines too. Okay? As long as you get them in what form? Okay, get them in that form. Does everybody understand? Now, on the notes today that you're fixing to watch, I show you another method. You can use an input-output table to do the same thing that we just did here. Okay? Here's the deal. On these graphs, from the vertex, you have a dotted line that goes right down the middle of it. This is called a line, maybe we'll write this down. It's called a line of symmetry. If I plot a point over here, what's the line of symmetry tell me? But I'm going to have a point where that mirrors it on the other side. You guys see that? So now, when I figured, I just have to figure for find the vertex, figure it for the one side, and then what happens? It's just going to be the opposite on the other side. You guys see that? So the first thing I show you on the notes is to find what? The find the vertex, and then everything works out from the vertex. Do you guys understand that? Hello? Let's communicate. Let's find out. Any questions? Okay, you guys grab a laptop, start on 4-7 notes. Okay, this one. Quickly, hurry up. Okay, still get it done.